Very good evening friends, and in this video we are going to discuss about the electric dipole. What is an electric dipole? Electric dipole is just arrangement where the two charges of the same magnitude but opposite nature are separated by a distance. Suppose this is D. This is called our electric dipole, and a quantity P bar is product of the charge, that is Q into D. This is called as our electric dipole moment. So D bar and the sense of direction, because if this is a vector quantity, Q is not a vector quantity, then D is a vector quantity, and its sense is from negative to positive. Like if I say that if I have point A and B, then it can be from AB bar. This is the direction. Now electric dipole is a very important phenomena, because in the chemistry you study that hydrogen fluoride, they are the polar covalent molecules, so they have charge on them, so this is a dipole. Hydrogen chloride have the dipole moment because hydrogen falls. This is called the electrovalent nature of the covalent compounds. Water also have dipole moment because oxygen develops a negative charge and hydrogen develops a positive charge. So these are again two charges equal in nature and opposite, and they are separated by a time distance. This is our electric dipole, however. And in this dipole, in this chapter, we are trying to find out the electric dipole of the potential, electric potential due to a dipole. So for that, I need to draw this is my dipole, minus Q plus Q, and this is separated by a distance. This is midpoint distance D. And then far away from this, there is a point where we are interested in finding the potential. So that goes like this, and here we have to join this distance. This goes like this, and here also you can join these two like this. Okay, from O to P, this is the point P where we are interested in finding the potential. This distance is R, OP. Now far away, because here in this situation we are considering P so far that R is much more compared to this distance D. So it means that we have this PA, suppose this is PA and this is PB. So we have to choose 2 points so that they can come in a straight line, so that we can find. So this is a geometrical construct. I'll drop a perpendicular from here on this. This is perpendicular. Same way I'll drop a perpendicular from here on this. Pardon me if the diagram is not up to date. Now this is the perpendicular, this is the bisector, so it means this is D by 2 and this is also D by 2. Now this is my A dash and this is my B dash. We are, since this distance is so far and this is just a tiny diagram, so we are into the app that PA is nothing but PA dash is PA dash, and the PB is nothing but PB dash. PB is PB dash. Because of this structure and this tiny distance, this is a possibility, because this R is so far compared to this D that this diagram is so tiny that you have to make this structure. I think this is just a mathematical construct. So now we have to find, because when we'll use this OR, so like OP is R, so for this value I need to find this. So this is 90 and this angle is theta, so this also will become theta. Okay, so what is this value? This value, this is 90, this is theta. So for this is 90, this is hypotenuse and this is my adjacent. So I get this value, this one, as d by 2 cos theta. And this will also be similarly, this part, this is theta, this is 90. So compared to, with respect to this point, this is adjacent. So this is also d by 2 cos theta. Now we are interested in finding the potential. So here you see, because you just saw that the potential formula we have, V is 1 over 4 pi epsilon naught Q upon R. So this is Q. So we have our potential. How can we find that potential? We will use this AP and this, and then for that we will have one value that is called as V1. V1 is the potential at P due to this A. So V1 will be 1 by 4 pi epsilon naught. What is charge? That is minus Q. So I will put it minus here. Q upon PA. PA, but the PA is equal to PA dash. So I will write PA dash. And what is PA dash? This is PA dash, and this will become minus 1 by 4 pi epsilon naught Q upon, this is R and this is d by 2. So this is R plus d by 2 cos theta. This is V1. Similarly, V2 will be 1 by 4 pi epsilon naught Q upon R minus, because from O to P this is, and we as in PB dash, so this part I have to subtract. So R minus d by 2 cos theta. So now this is a scalar quantity. Potential is work upon charge, and it means the potential is a scalar quantity, so we do not need the vector sum of all this. We can simply just add them, and we have the condition that the potential at P due to this minus P and the plus Q will be given as V equal to V1 plus V2. So now you see that the V1 and V2, we have this Q over 4 pi epsilon naught common. So Q over 4 pi epsilon naught common, and then I have 1 upon R plus d by 2 cos theta plus 1 upon R minus d by 2 cos theta, and that is Q over 4 pi epsilon naught. Now this will come on this side, so minus R plus d by 2 cos theta plus R plus d by 2 cos theta upon product of these two, that is R square minus d square by 4 cos square theta. Now R cancel. D by 2 cos theta plus d by 2 cos theta will become d cos theta. So from here I go to this point, and this is V equal to Q over 4 pi epsilon naught d cos theta upon R square minus d square by 4 cos square theta. So that is R square minus d square by 4 cos square theta. Now if you just pay attention to this, then there you will find that this R is much more greater than this D, it means r square will also be much more than the d square. So what you conclude, that you can separate these two, like you can ignore this part because this part is too small compared to r square. So we will have our v 1 by 4 pi epsilon naught d cos theta upon r square. This is the value of the expression for the potential due to an electric dipole, where the point is situated on the line perpendicular to the axis of the dipole, and we have got our relation v is 1 by 4 pi epsilon naught q. Oh, I missed one thing. There is q upon this, so I missed this q part. So qd cos theta. Now since p bar is qd, then you can also write v is 1 by 4 pi epsilon naught p cos theta upon r square. Now this you can consider as your final answer, final values of the expression rather than that one. So thank you very much. This is all for this video, and in the next video we will learn some other important features of the electric dipole. Thank you very much.